Pimpi ma wo fafu wo yi. Me ma wo soda. Ni monya fue. Mi peja mudido. To me ni fue ye. Ebe yi wa yo. Nadie ebe ma wo so. La shawe namda. Pimpi ma wo fafu ye.
Good day, my friends, and welcome to today's lesson on indices. Indices has become one of the major topics that normally worry students. Though it's very simple, sometimes it gives issues if you are not able to find your way out. Okay, so in this video and perhaps the next part of the video, we shall look at the whole comprehensive lecture on what indices. Now, when we say indices, what does it mean? It's simply a number to a power. Okay, a power. So we have the base, and then we have what? The exponent. So x squared, x cubed, x to the power 4, and the rest. They are all index numbers, right? So indices. So just normally indices. So we have this, and then the index, right? So for instance, I have this one here, a to the power n. Okay, they will refer to the a as what? The base, and then we will refer to this as what? The exponent. This is what I mean. So we refer to a as the base, and then we refer to what? N as the exponent. Now, for the purposes of our lessons, we have to be referring almost all the things they've given us into what? Various base and then what? Their exponent. But the basis must normally be same throughout, okay? The basis must be same throughout. So we have to get the common base and then their various exponents, okay? Now, in order to do that, we need to study the various laws that are guiding what? Indexes, okay? The various laws. So there are some few laws that we look at. If you master all these laws, then that's all. You don't need anything about indices anymore, okay? Anything you are given to, just a combination of the laws, okay? So the indices first law, the law of what? Multiplication of indexes. Supposing you have an index, say a to the power n, right? A to the power n, index number, and then this is multiplying a to the power n. You realize that the bases are what? The same. Like I told you, before you can apply any law or anything, the bases must be the same before everything else going to go. So if you're having two of this numbers multiplying each other, and you realize that the bases are the same, then we say that, okay, then I can rewrite this as, we write a base, okay, and then we sum the exponent. So m plus what? N. That is the very first law of what? Index. So for instance, if I give you x to the power 3 multiplying x to the power 4, you realize that the bases are x and they are the same. Hence, my answer is just going to be maintain your x and then you sum the exponents. 3 plus 4. Then this is going to be x to the power 7. Very simple. Okay, so then you simplify that particular expression. Okay, so that's the very first law of what? Indices. Now the second law is, if you have a to the power, say m, if we do multiplication, we must do division, okay? Divided by a to the power n, where m and n are any real number, okay? Any number. It can be any number. And a to b is any number. So then a to the power m divided by a to the power n. Then we say that, okay, I can actually bring this up here. Okay, so that it becomes what? A multiplication. Then in that case, this will become the base which you are dealing with to the power of m, then minus of what? This. So m minus what? N. So that's the difference between the two. You know, one thing is that the opposite of multiplication is division. Therefore, the opposite of what? Addition is going to be what? Subtraction. That is one thing you need to know. Okay. So if these ones are opposing, then this must also oppose. So supposing I give you x to the power 7 divided by x to the power 6. This one clearly you should just know that x to the power 7 minus 6. And that's x. Simple. Very, very simple. Very, very simple. We are only following what the law is saying. Very well. Now, supposing we have, that's the third law. Supposing we have an index already, right? So we have this a to the power m. And then we are further raising this to a new power. Okay, a to the power m. And we are further raising it to what? A new power. Then in that case, my a still maintains its position. But then the powers are going to what? Multiply. Okay? So the powers are going to multiply. So you have m times what? N. So if you have something squared and you are squaring it again, then the base will not be affected, only the powers. So for instance, let's say I have this. I have that x to the power 5, and I'm squaring this again. Then this is going to be x to the power 5 times what? 2. So that's x to the power 10. Simple. Okay? Simple. It is because of this law that we were told in most of our math lectures that whenever you square a square root sign, it goes away. It is because of this law, right? So a square root simply means raised to the power half. A cube root means raised to the power 1 over 3. Any root means 1 over that value, right? Okay. So then x to the power half. So when I square this, then it brings me back to what this law is saying. So that root sign you are seeing is the same as x to the power half. So when I square it, then this becomes x to the power half times 2. So then these two will cancel this, and so I'll be left with x to the power 1, which is the same as x. That is why they tell you, in order to remove the root sign, just square it. They are applying the third law of what? Indices. Okay? They are applying the third law. Okay. Now, the fourth law. Supposing I'm having this 1 over a to the power m. 1 over a to the power m. Then I can write this one in a linear form, not a fraction like this. You can write it linear one, where a here, and then the exponent is going to take the opposite of this power. So take it as if the over sign here is what has appeared over there. Okay? So when you establish something like this, then it's very easy to see this. Okay. Now let's go to the fifth law. The fifth law, let me clean this side. Okay, I'll clean this side. So let's go to the fifth law. So supposing we have something like this. So we have a and then b, all to the power n. Okay, we have two numbers already multiplying themselves, and then we are raising it to the power. Then in this case, this is going to be a is going to carry the power, multiplied by b going to carry the power. So a is going to carry the power, and then b is equally going to carry the power. This is multiplication. It's going to carry the power. So for instance, if I have 2 times 3 inside this and I square, this can be 2 squared times what? 3 squared. This is what we do. Okay, 2 squared times 3 squared. Right. Now, if it is so for this, then it should definitely be the same as if I have a over b raised to the power n as well. So if you have a over b raised to the power n, then whatever happens to this should be able to happen to this as well. So then here it's just going to be the a is going to pick the power, and then the base as well, the denominator is also going to pick the power. So these are some of the laws of what? Indices. These are some of the laws of indices. Okay. So I believe you are writing the laws. Very soon we will start using them in solving certain questions. Okay, and you see, when you have these laws at your fingertips, indices is not a challenge. Alright, so now let's continue with the laws. So number 7. In case you have two index, right? And then they are equating. Okay, they are equating. So for instance, I have a to the power m, and this is equating a to the power n. Okay, I'm having this situation. Then all these things is on the assumption that the bases are the same before you can. So if the base here is the same as this, don't go and say 2 to the power 3. Okay, let's say 2 to the power x is equal to 3 to the power 7. Then you start doing something. The bases here are not the same. So this one alone, it don't even have relation. In that case, you just solve this. You punch this on your calculator. Whatever value you get, then you use it. Okay. But at the level, they will give you things that you can actually make. After you take excellent log of this. Okay. So then here, if the bases are the same, like you see, then this is going to be a here. Then you equate. Okay. The bases are the same. So if we are equating it. So in this case, the bases are the same, so you can then forget about the base and then what? You equate the powers. Okay? So provided the bases are the same, you have the right to equate the powers. So now with these few laws of indices, we can actually go on to solve any index problem at all we are faced with. Any index problem. So for instance, the very last law, if I give you something like this, 2 to the power 2x is equal to 2 to the power 9. You can easily do this. The bases are the same, so we can then equate the exponent. So 2x should be equal to 9. So we just find x, which is 9 over 2. Simple as that. Okay, 9 over 2. Okay, good. So now, with the laws established and understood, let us actually proceed into solving some examples that has the combination of laws. That is equations involving indices. But before I go there, there is one last law. When is this? If you have any number raised to the power 0, the answer is always 1. If you have any number on this planet Earth raised to the power 0, the answer is always 1. It's always. I'm not saying sometimes, it's always 1. Okay? The answer is always 1. So these are the laws you need to keep with you for the exams. So now let's go to solving numerical. So now let's look at this example. Supposing you are asked to evaluate the 64 over 25 all raised to the power negative half. Okay, 64 over 25 all raised to the power negative half. Now when you see this, you remember one of the laws that I look just like this. Oh, okay. There was a law that was what? A over B to the power n. If you remember that law. It looks just like that. Okay. So this time around, my A is my 64. My B is my what? 25. And then my n is what? A negative half. Okay. Good. So then, in that case, we said that the answer to this specific one is going to be a to the power n over b to the power n. So hence, when we have this one too, we do the same thing. 64 to the power minus half, and then what? 25 to the power minus half. So 64 to the power minus half, 25 to the power what? Minus half. Now, when we say minus exponent, we saw that, right? So we saw that when we were having 1 over a to the power n, we said our answer is a to the power minus n. So minus exponent means that 1 over a positive of that, right? So if I'm having 64 to the power minus half, then it's just like this. So I can rewrite this as what? 1 over what? 64 to the power half. Okay? 64 to the power minus half, I can write it over 1 over 64 to the power half. Okay. Same way, 25 to the power minus half, I can rewrite it as 1 over what? 25 to the power half. I see. Good. So it means over here, I'm going to do 1 over 64 to the power half. Okay? All this divided by the 25 as well, which is 1 over 25 to the power half. So I've been able to remove the negative and made it this way. Okay? I made it this way. So if you want to use this, the rest is just algebraic expression. You have a fraction divided by another fraction. Though you know your algebraic expression will tell you, then you can change this one to multiplication and then you swap the second. Okay. So then this will become 1 over 64 to the power half. Okay. Then that one times, then you swap the position of this and that. So 25 to the power half over 1. Okay. 25 to the power half over 1. So basically, what is 25 to the power half? We established that raised to the power half means what? The square root. Okay. Raised to the power half means square root. So what they are actually asking is 1 over what? The square root of 64 times the square root of 25. So square root of 25 is 5. And then the square root of 64 is 8. So your answer becomes 5 over 8. Okay. These ones, they are very simple. Even by punching it on your calculator, you can get your answer. Okay. Very, very simple. Now, let's look at a question in this case. Say, I'm giving you 6x to the power 5, y to the power 7. And I said this is divided by 2x to the power 2, y to the power 9. Okay, and I ask you to simplify this. It's very simple. Okay, it's very simple. As for the constants, they are constants, so you can actually do it. So you can say, okay, 2 into itself 1, 2 into 6, 3. Okay, so I've reduced this to become 3x to the power 5. Y to the power 7, all divided by s squared times y 9. Okay, s squared times y 9. Good. Now, you remember that with this law, the division law of indices says that when two indices are dividing and the bases are the same, so treat this as if there is no 3 and there is no y. So we are dealing with only the x's. Okay? So you realize that x to the power 5 is being divided by x squared. So we remember that if we are having an divided by an, then we say the answer is an minus n. Hence, that's also what is going to happen here. Toward both the x and then to the y as well. So then this one, bring the 3 out. Then here, the x is going to be x to the power 5 is the one at the top minus this guy goes there, so minus 2. Are you seeing that? And then this one followed by y to the power 7. Then this is going up, so minus 9, like that. Okay, like that. So this is like this is dividing this. So you apply that. This is also dividing this. You apply that. Are you okay? Good. So at the end of the day, 3 x to the power 5 minus 2 is 3. So x3. Then this is y to the power minus 2. Okay, y to the power minus 2. So at the end, you are going to have what? 3x to the power 3 over y squared. Because y to the power minus 2 means it should come down. When it's at the top and it is minus, it means it should come down. When it's at the down and it's minus, it means it should come up. Simple strategy. Okay, simple strategy. So then this becomes what? Your final conclusion or your final answer for this. Okay. So these are some of the questions. Right. Now let's look at another one. Let's suppose I'm giving you this. 3 2x plus 5. So 3 to the power 2x plus 5. Okay. This is equal to 1 over 81. So we are having 3 is equal to 2x plus 3 to the power 2x plus 5 is equal to 1 over 81. Okay. So we know definitely that here the equation will only work when we are able to change whatever is here to a base of 3. You remember? Because we said that for that particular law, a to the power n should be equal to a to the power n. So the basis must be the same. But this time around, this doesn't even look like 3 to the power something. So you must make sure it looks like a base. The 81 is something with what? Base of 3. Okay? I'm doing base of 3. Okay. So we all know that this one cannot be simplified. So 3 to the power 2x plus 5 is equal to 1 over. Now we can make 81 a base of 3. Okay, so 3 to the power 4. We all know that 3 to the power 4 is 81. Okay, 3 to the power 4 is 81. So then we cannot equate them because that's not what the law says. The law says they should be on the straight line before we can equate the exponents. So it means that we need to apply the negative law we knew. That's 1 over a to the power n, which came to negative n. You need to apply that. So you see, one question, you are applying so many laws. That is it. When you know the laws of indices, simple. Okay. So then this will change using this format. So then this 3 to the power 2x plus 5 is equal to 3 to the power minus 4. So now it's resembling this. Okay. And this is now resembling this. So when it's resembling that, then we can only do it. Equate the exponent, which is 2x plus 5. This is equal to minus 4. And hence you can make x the subject. 2x is equal to minus 4 minus 5. So 2x is equal to negative what? 9. Hence x is what? Minus 9 over what? 2. That becomes what? The value for your x. So everything here then becomes linear equation. But to change it from this format to this format, you need to have the rules at your fingertips. Another example on this, very simple. Let's say we have this 2 times 2 to the power 3x is equal to 8. Okay, so we have 2 times 2 to the power 3x is equal to 8. We have this question here. Now, we need to get it in the form this before we can solve it. So let's start. If you remember the very first law, which is multiplication of what? Indices, we said that when you have 2 indices with the same base, you add the exponent. Okay. So you know that this 2 that is standing as a whole number is an index, but the index is 1. Okay. So any number is raised to the power 1. Are you okay? So then these 2 times this, then we know that the bases are the same. Therefore I can say 2, then I'll add the exponents together. So this is going to be 3x plus what? 1. And this is equal to 8. Okay? It's equal to 8. So then 2 to the power 3x plus 1. We must make 8 also have what? A base of 2. Okay? So we know that 8 here is going to be 2 to the power 3. So with 2 to the power 3, then we can then say that it's at this level now. So we can equate 3x plus 1 should be equal to 3. And when you send this here, 3x is equal to 3 minus 1, which is 2. Okay? Hence my x is what? 2 over 3. And that is that. So that's going to be your x. So these are simply trying to solve equations involving what? Indices. And that one, you combine the laws and you must always get to this point. Then you can equate the exponents. Okay? Irrespective of how the question is placed, you must always get it before you can get the value for your x. Okay? So basically, in indices, just learn the laws, master them like the way we did, and then you can then pick examples and you see how simple the examples will be. Right? You know, I only give you like that. Free. I need to leave you with this assignment. So kindly do this and then contact us if you have any challenge, okay? Then we are willing to assist you. Right. Now let's go to a special case when it comes to indices. But this time in our next video on indices. Thank you very much and have a
my crown is a woo, be a rainy wall. My crown is a woo, be a rainy wall. My crown is a woo, be a rainy wall. Why may you yo, Masha when you number. My crown is a woo, be a rainy wall. My crown is a woo.